Okay, we'll go ahead and get started. If anybody doesn't have a pen, let me know.
I sure do.
And what is today? First day of spring. Let's get some sunshine while we can. Everybody agree?
Yeah. Do it.
You got problems, Ross? We need to go outside and talk? Okay. Anyway, Scott's going to talk to us today about lockout, tagout. It's very important here and at home. So please take it away.
Well, good morning, and thanks for everybody being here. There's some empty seats, so I think you guys maybe had some March Madness flu. That what happened here. So kudos to all of you for coming. As you can tell, and as he said, we're going to talk about lockout tagout. And I'll go ahead and kind of say this is a little bit of a difficult subject to relate to some of you in the room that don't spend time in the shop and or out on the job sites. So I ask for you, those of you, to bear with me here, that this is a very important subject, and it's one of those life-saving types of subjects. It's one of those things that if we fail to do some of these things when we need to do them, they can have very dire consequences. And so there's enough of you that spend some time in the shop, and there's enough of you that spend some time out in the field, that it's important that we talk about this. Lockout tagout is it's the OSHA standard for the control of hazardous energy. Okay, so that's hazardous energy is a pretty broad subject, and unfortunately, a lot of times when we think about hazardous energy, we just simply think about electricity. And so one of the things that we will talk about in this program is how it's not just electricity, and that's a mindset that we have to make sure that we get away from, because there's lots of sources of energy, and electricity is just one source of energy. So we're going to focus on that. But what the standard says is that we have to control all sources of hazardous energy anytime that we're servicing or maintaining a piece of equipment. So that doesn't mean that you only have to use lockout tagout when you're going to tear a piece of equipment down to the bare bones. It means we have to use lockout tagout when we're servicing and maintaining. And so I think a lot of times we think, well, if we're not doing this great big, serious maintenance project, that we don't have to worry about it much. But the standard doesn't say that, and it's unsafe anytime that we're going to come exposed to those sources of hazardous energy. A couple of definitions that will help all of us out is that there's authorized employees and there's affected employees. And the definition of an authorized employee is an employee who performs that service and maintenance. Okay, that's the person that has the locks assigned to them. That's the person that's going to isolate those energy sources and lock a piece of equipment out. Okay, now you move on to the affected employee. That's the rest of us. We're the ones that might be working around a piece of equipment that's subject to lockout tagout. We might be the one that they say that the authorized person says, hey, I need you to try to operate this piece of equipment. I've locked it all down. Can you try to run the piece of equipment and get it to cycle? Okay? Or we might just be simply walking by a piece of equipment that's locked out. That's us. We're affected people at that point. We might see somebody has unplugged something from the wall, and we might just be walking by and think, oh, this is usually plugged in. Somebody unplugged it and reached down and plugged it in. We're affected people when we're working around those pieces of equipment that are subject to lockout tagout. So it really does affect a lot of us in the room, even though we're not the ones out there locking out pieces of equipment, or maybe we're not even the ones out there doing the service or the maintenance. I said there's lots of sources of energy: mechanical, hydraulic, pneumatic, chemical, thermal, and lots of other sources. Gravity. There's lots of sources of energy. And what I always challenge people to is that when you think of a piece of equipment and kind of a proper procedure for figuring out how to lock out a piece of equipment is kind of going through a checklist and saying, okay, what are all the energy sources this piece of equipment has? And you go through and you start out electrical, pneumatic, well, there's gravity, and you start figuring out all the sources of energy, and then you go back and you start figuring out each one of those sources of energy, how am I going to isolate and control that source of energy? And what I tell people is that I don't think, and I'll open it up to this floor, I think of a piece of equipment that only has one source of energy. I will tell you, I've been doing this a really long time, and I haven't ever had anybody successfully tell me a piece of equipment that has only one source of energy. Anybody think of anything? I can still make that statement then the next time I do this class, can't I? But thermal, you know, all of those sources of energy, there's always a primary source of energy, and then there's all these secondary sources. And the point is, obviously, that we need to make sure we consider all of those. A lot of times when we're discussing lockout tagout, we talk about the fatal five. These are the fatal 5 things that we could do that causes, you know, really bad consequences. The first thing is that we're going to try to do any of that service and maintenance and we fail to stop the equipment. Okay? I'm just going to reach in real quick. It's only going to take a second. I don't want to disrupt the whole process. I'm just 1 second. And so many times when you're investigating an accident, that's what comes back to you. I didn't want to shut it all down. I was just that little piece of stuff. I just need to get in there and grab it real quick. I didn't think anything would happen. And now we call them, you know, 9 fingers Mo or something. You know, they lost digits. Failure to disconnect from the power source. Okay. Failure to disconnect that electrical energy. Failure to disconnect that pneumatic energy, that hydraulic energy, that thermal energy. But failure to disconnect from the power source. Failure to dissipate residual energy. What are some things that might have residual energy in them? I'm sorry?
Compressed air.
Okay, compressed air lines. So we've got some stored pneumatic pressure. Hydraulic, we could have that. We could have capacitors that have some stored energy in them, some stored electrical energy. We could have springs that have stored kinetic energy. We've got, you know, mechanical energy. If you unplug a circular saw while it's moving, do we still have mechanical energy to deal with? Absolutely. That blade doesn't stop right away. So we have to make sure that we take care of all those stored energy sources. Those are secondary energy sources as well. Also, accidental restarting of equipment. It can't possibly restart accidentally if we follow all the procedures that we should follow to shut it down. Okay? If we've addressed all the energy sources, we've released all the secondary energy, and we've locked out and blocked all of the potential energy sources, we shouldn't ever have accidental restarting. That's only going to happen if we skip a step or we don't think it all the way through. So we have to always think it all the way through. Failure to clear work areas before starting. Okay? Whether that's people, whether that's material, whether that's finished product. But a lot of times people don't clear that area, and then they start a piece of equipment up, or you know, the accident occurs because they haven't cleared the work area. And also, I'll even extend that further to haven't cleared the work area after the maintenance has been done. And so now all of a sudden tools are left behind and parts and that kind of stuff. And you either damage the equipment when you restart it or potentially projectiles and that sort of thing that cause injury. So those are the fatal 5. Some of the, the scope of the lockout tagout requirements. Some covered activities of constructing, installing, setting up, adjusting, inspecting, modifying, maintaining, servicing, where employees could be exposed to unexpected energizing or release of hazardous energy. Okay, so that's a pretty big list. I mean, you can almost throw just about anything that we're doing out there. When we take a cover off, when we remove guards and we start doing some work, that we probably fall into one of those activity categories. Some of the rules of lockout tagout that not only are OSHA rules, but they're part of your own policies for George Cook Sons, is the equipment must be de-energized and locks or tags must be applied to the devices when servicing maintenance activities. And here's some take that a little step further. When an employee must either remove or bypass machine guards, okay? So that's kind of the first red flag that says, if I'm going to take a guard off, then I automatically need to be thinking, have I followed the lockout policies? You know, have I done everything that I can do to isolate and control those hazardous energy sources to make them not hazardous? So as soon as you take that guard off. And then also, the employee is required to place any part of his or her body in contact with the point of operation. And the point of operation is very simple. That's where the rubber meets the road. That's where the blade meets the stock. That's where that's where the parts come together. It's the knit points. It's where the action's happening. So if I have to place myself or any part of my body in the danger zone of that point of operation, then I need to make sure I'm locking out and tagging out. And we've learned through some pretty vigorous fights, right, Todd, that it's not always okay to just say, well, we've got electronic curtains or we've got two-hand controls and all that. That, I mean, I'll tell a story about you and I. We had to drive to Frankfort, Kentucky to fight vigorously with the OSHA compliance officer and his boss over the fact that we felt like we had proper controls, didn't need lockout tagout because we were adequately controlled with kind of a double system that both systems failed, and they argued that we should have locked out because we didn't test to make sure our systems wouldn't fail, and it was long. We were successful, by the way. We took us a while though, didn't it? Well, we took $21,000 down to $7,000. Let's put it that way. I call that a win. But Susan, do you call that a win in the accounting department?
Well, I don't know. What about that 7?
I tried to stay away from there.
Well, I call that
I tried to stay away. I knew better. Welcome, Ray.
Hey, I come from the insurance world. If you can settle a $21,000 potential claim for $7,000, you did well.
Right.
One of the key points to that, though, that we struggled with, we were not checking our buttons. We did not have a maintenance program that showed that on all of our stops, we've done a routine maintenance program. And that is defined that you must be doing that. You must show proof that you have done those things.
Which is why we couldn't make that all go down to 0.
And had we done that, we would have noticed we had a fault in our palm control buttons, and we didn't. And so that's why the accident happened. He never lost half of his finger. So
Do we do that now in the shop? With all our, we have light curtains
I would say
and
it's
floor
like-
mats?
Like
Everyone is responsible for safety.
well, I just said I don't know if you do that or not.
I don't know either.
At the speed.
I don't know.
Well, the light curtains are checked. I don't know the two-hand controls are checked.
About the floor mat on the faucet?
We need to check because it's something people don't think of. That's why I brought it up. It's something we need to
I think
remember.
that checking them and documenting that we're checking them are two different animals.
And you have to have proof documentation that they've been checked.
Also, the third thing there is the employee is required to place any part of his body into the danger zone associated with the machine operating cycle. So not just that point of operation, because we might be getting into a backside of a piece of equipment where there's a lot of gears and stuff happening. So that is another trigger. Bottom line is, if we're performing maintenance and we're going to take a cover off, then we need to be doing these lockout tag out. This just basically is saying, and because I get a lot, it's easier to tag something out than it is to isolate energy and lock it out. But the standard specifically says that, I mean, it's acceptable to tag out in place of lockout, but if it's capable of being locked out, it's not acceptable to just tag it out. So if it's capable of being locked out, then locking out is necessary. If it can't possibly be locked out, then we can tag it out and that can be used as a substitute. But you can't just do one or the other just because one put the tag on it's easier. These are just a few pictures. I think most of you probably have seen this stuff before, but you know, there's devices to lock valves so you can't turn valves. You know, bigger valves, you chain, like the fire systems, a lot of times just a chain goes through it so you can't turn them and close them. There's a series of valves locked out. Kind of difficult to see, but this is actually it's one of these, which is what you have to have if you have more than one person. If you only have one lockout point, but you have 4 or 5 people working on it, you need 4 or 5 locks on it. And sometimes that's difficult, so you can use a multi-hasp there. So those are just some examples. Here's where they've tagged out a emergency stop button. They pulled it out, tagged it, so that somebody doesn't push it back in. Now, if I saw that, I would want to go to the, I'd want to see somewhere that was actually locked out. It's great that they tagged it out because that's just informational. That's telling me it's locked out, don't operate. But I would want to go find somewhere that's actually locked out and it's not that passive system.
The key to your tag is to know if upstream or downstream there's an actual lockout point, right?
Mm-hmm.
So a lot of times you use that as an indicator, especially for long runs.
It's most of the time, or a big important element of lockout tagout is communication. You know, communication between those affected and authorized people, and those tags, like Todd says, that's a way to, you know, anybody that all the affected people that want to come operate that piece of equipment, they can read that tag, and they should be able to read it. It says don't operate, and then it's going to tell who locked it out. So if I have a question that says, you know, Steve Whitehead locked this out. Well, now I know I can go to Steve and say, hey, I need to use that piece of equipment. Why is it locked out? And then he can inform me. So it's communication is very important. Just some of the things that happen when somebody is going to prepare for a shutdown or a lockout is that it's very important to know the types of energy that power that piece of equipment. So all those energy sources we just talked about, it's important for that person, that authorized person, to understand all of those. It's also kind of important for some of that stuff to be done ahead of time. The time to figure all that out isn't when you're getting ready to lock out the piece of equipment. It's ahead of time. Somebody sat down and said, this piece of equipment, here are all the energy sources, and this is how you lock them all out. Know what the hazards of the energy are, and know how the energy can be controlled. So that's kind of the authorized person. I don't expect you all as affected people to be able to know all that, okay? As affected people, you need to know that when I go and I see something locked out or tagged out, not to disturb it, not to try to operate it. But authorized people, these are the things they need to know. They're also going to shut down the system by using the normal operating controls. So if there's an off button, I'm going to turn it off by normal operating controls. And then follow whatever procedure is right for the equipment to shut it down. So like I said, just normal, like shutdown for the end of the day type of shutdown is the first step of a lockout. Then they're going to operate all the energy isolating devices so the equipment is isolated from energy sources. And they're going to be sure to isolate all the secondary sources as well. Then they're going to apply the devices, and they're going to lock out everything that they can lock out, and they're going to tag out everything that they can tag out. And I made in red that standardized devices because That's an important element of lockout tagout, is that you can't just go grab the lock that you lock your lunchbox or your toolbox with and use it as a lockout tagout device. They need to be standardized and they need to be identifiable to the person that locked it out. So whether it's a color coding system and each authorized people have their own color, or whether it be a lock that actually has their name on it or a number on it, but I need to be able to identify who applied that lock. And so they're going to place all the locks and directly on the energy control places, and then they're going to, when more than one lock is used, every employee must attach his personal lock. So we talked about it a minute ago with that HASP, is that if there's 3 of us going to do maintenance on that piece of equipment, all 3 of us need to have a lock on there. Okay, I can't rely on, somebody else's lock, because when they get done with what they're doing, they're going to remove their lock. Okay, and that's how it works. When I get done with what I'm doing, I remove my lock. When all the locks are removed, it should be ready to be operated. So everybody has their own lock on the piece of equipment. Then they're going to release any stored energy, trap pressure. They're going to block anything that can come down, any gravity source of energy. If it's something that's being held up by, if it's a press or something that's being held up by hydraulics, we're not just going to lock out those hydraulics and then assume it's okay. We're going to block those so that they can't come down on us. Bleed lines and vent, make sure vent valves are open, and make sure stored energy can't reaccumulate. Make sure the danger areas are clear from people, and then verify that the main disconnect switch or circuit breaker is shut down. And then once they've done all of that, then they're going to try to operate the equipment. They're going to try to get it to go with it all locked out. And so if they feel like they've gotten all those energy sources controlled, now they're going to try to operate the equipment to see if it in fact is controlled. If they try to operate it and they can't get it to operate, then they can consider that piece of equipment locked out at that point. And they can start doing the servicing or maintenance that they were supposed to do. I won't go through all these step by step, but now we're reversing all of those steps when we start to remove the lock. And again, one of the most important features of this is communication. Letting people know, hey, maintenance is done on this. I know that this project's been down for a month, or this equipment's been down for a month, but all you affected people that work around this piece of equipment, we're going to be removing the locks and it's going to get going again. So it's kind of like, if you've been driving down the road for a long time and there's a stop sign always there, and now all of a sudden they remove the stop sign. Okay, communication's pretty good. Like, it'd be real nice to have a sign up there for a couple of months saying, hey, in 3 weeks we're going to remove this stop sign, so you can start getting your brain used to the fact that there's no longer going to be a stop sign there. This is the same way. We're going to communicate to people that, hey, we're going to be taking these locks off. I know you're used to this equipment not being energized, but now we're going to energize it. Communication is king. Contractors, they need to follow our lockout tagout policy, and for those of you that work in the field on projects, we need to make sure that our contractors that are working under us are following lockout tagout procedures. We are responsible. If they're sub to us, we're responsible to make sure that they're following the lockout tagout policies that we have. Anytime that there's a shift change, servicing lasts more than one shift, that has to be coordinated. And then if somebody leaves their lock on and it's time to remove the locks, there needs to be a procedure where that person's supervisor is contacted to make sure that there's not some important reason why they didn't take their lock off. So once they've communicated with that person, then the supervisor can cut the lock or open the lock. Lockout devices need to be durable. They need to be able to withstand the environment that they're exposed to. If that's a wet environment, if that's an acidic environment, if it's a hot environment, they have to be able to withstand that environment. We talked about being standardized already. I need to be able to see that that's a lockout device. Okay, I don't need to spend 5 minutes trying to decode whether that's a lockout device or part of the equipment. It needs to be standardized, and I need to be able to recognize it. Substantial. What do you think a lot of people try to do lockout? Like zip ties. I won't even ask the question, I'll just offer. Zip ties, okay? That's not substantial. Anybody with a pocket knife can remove that, okay? It needs to be substantial enough that it requires some force to remove, some forethought and some force. So, can't just use a zip tie. Talked about identifiable already. Periodic inspections, when we do have our procedures, like our policy, we need to review our policy and make sure it's current. Periodic means annual in OSHA's mind, or as changes are made. Also, when we have specific procedures for locking down a specific piece of equipment, we need to review those annually to make sure that nothing's changed. You know, that electrician didn't come in, and we may have said at one time that we need to go to breaker box B and lock out breaker 19. Well, maybe electrician's done some changing, and now it's breaker box B, breaker 21, and that needs to be reflected in our procedures and changed. That's kind of it for lockout tagout. And I know that most of us are affected people, not authorized people, but it is a hot button for OSHA. It is a serious source of injury. Most injuries that happen as a result of failure to lock out tagout, they're not minor. They're not the cuts and the scrapes and the bumps, okay? They're the lost fingers and arms and that kind of stuff. They're really bad. And I did spare you because this PowerPoint had a really nasty amputation picture in it, and I thought maybe I wouldn't show it. But if I need to, if you're not following these policies, I'll put one on there and I'll scare you. A lot of you have heard me talk about that. When I first started as a safety professional, working at the penitentiary, one of the first accidents I investigated was an amputation because of a failure to lock out. And it was an inmate whose arm was ripped off at the shoulder joint. 100% avoidable had they followed proper lockout. And that had a pretty strong impact on me very early on in my safety career, to be interviewing a guy that, 3 days earlier had 2 functioning arms, and today he's missing one. And for probably the better part of 2 or 3 weeks, I was being wrapped up in like washcloths, parts of this guy's arm and fingers, saying, they come in and say, do we need this? What do we do with this? And like, please don't bring fingers in and put them on my desk. But it had a pretty strong impact. So it's very important, and OSHA takes it very seriously as well. Are there any questions? Yes.
A little bit off the subject, but we have a very active training going on through here. What's the game plan if, one of these tanks of liquid oxygen, nitrogen, sulfuric acid, what's the game plan to evacuate besides run out there?
We've thought about that a lot. It's been discussed a lot. And the reality is that if we have a training derailment or a release, that we don't know if it's the right thing to do to hunker down inside the building or to evacuate and get out of the building, because it's dependent on what ethyl methyl bad stuff was coming through. And so, well, unfortunately, you may think I'm going to get out of here, and the worst thing you could have done was run out in some cloud. Okay? So what we have decided is that, or what has been decided, I didn't have a lot to do with it, but what has been decided is that we're really going to have to, we're at the mercy of the police authorities and the train authorities to give us direction about what we're going to do in the event that happens. Because you really could, depending on the prevailing winds, you could run outside and be the worst thing possible, and you laid in the parking lot incapacitated or worse.
I thought we were going to send Don out to test the atmosphere.
But if he doesn't come back.
We're sales guys. This is the sales department. Don, you take on that test. You'll be our back in the coal mines, what they have, the pigeons?
Get along,
Canaries.
Doc.
You're gonna be our canary. Why were you hired to be here at George Cook's Sons? I don't know, they keep calling me the canary. Any other questions? Well, thank you all very much. If you don't mind filling out your training aid, if you haven't already, and leave them on the corner over here, I appreciate it. Have a great day, and good luck on all your brackets.